Namaste students. The previous session we have seen the domain and range of inverse trigonometrical functions. This session we are going to see properties of inverse trigonometric function. First property, sine inverse of 1 by x is equal to cosecant inverse of x. The domain value should be x is greater than or equal to 1 or x is less than or equal to minus 1. Second one, cos inverse of 1 by x is equal to secant inverse of x. The domain value should be x is greater than or equal to 1 or x is less than or equal to minus 1. Third one is tan inverse of 1 by x is equal to cot inverse of x. The domain value should be x greater than 0. To prove the first result, we put cosecant inverse of x is equal to y. This is equation number 1. That is, x is equal to cosecant inverse from left to right, it is cosecant y. Therefore, the reciprocal of the two left hand side and right hand side is 1 by x is equal to 1 by cosecant y, that is sin y. Hence, sin inverse of 1 by x is equal to y. By using equation number 1, y is replaced by cosecant inverse of x. Therefore, sin inverse of 1 by x is equal to cosecant inverse of x. So what is sin inverse of 1 by x? Which is equal to cosecant inverse of x. Similarly, we can prove the other results also. Second property is sin inverse of minus x is equal to minus sin inverse of x. X belongs to closed interval minus 1 comma 1. Second, tan inverse of minus x is equal to minus tan inverse of x. X belongs to real number. Third one, cosecant inverse of minus x is equal to minus cosecant inverse of x. Modulus of x is greater than or equal to 1. First result, I am going to prove it. Let sin inverse of minus x is equal to y. This is equation number 1. Minus x is equal to sin inverse from left to right, sin y. So that x is equal to minus multiply both the sides. X is equal to minus sin y. X is equal to minus sin y is sin of minus y. Hence, sin inverse of x is equal to minus y. By using equation number 1, minus sin inverse of minus x. Therefore, sin inverse of minus x is minus sin inverse of x. Similarly, we can prove the other results also. Third property is cos inverse of minus x is equal to pi minus cos inverse of x. X belongs to minus 1 to plus 1. Second one, secant inverse of minus x is equal to pi minus secant inverse of x. Modulus of x is greater than or equal to 1. Third one, cot inverse of minus x is equal to pi minus cot inverse of x. X belongs to real number. First one, I am going to derive it. Let cos inverse of minus x is equal to y. Minus x is equal to cos inverse from left to right is cos y. So that minus multiply both the sides, x is equal to minus cos y, which is equal to minus cos theta is cos pi minus theta because it is in the second quadrant. Therefore, cos inverse of x is equal to pi minus y. Then by using equation number 1, pi minus cos inverse of minus x. Hence, cos inverse of minus x is equal to pi minus cos inverse of x. The remaining two results, the same way we can prove it. Then fourth property, sin inverse of x plus cos inverse of x is equal to pi by 2. X belongs to minus 1 to plus 1. Tan inverse of x plus cot inverse of x is equal to pi by 2. X belongs to real number. Cosecant inverse of x plus secant inverse of x is equal to pi by 2. Modulus of x is greater than or equal to 1. I am going to derive only the first result, sin inverse of x is equal to y. Then x is equal to sin y. Sin theta is nothing but cos 90 minus theta. Therefore, sin y is replaced by cos pi by 2 minus y. Therefore, cos inverse of x is equal to pi by 2 minus y. y is replaced by sin inverse of x. Therefore, pi by 2 minus sin inverse of x. Hence, sin inverse of x plus cos inverse of x is equal to pi by 2. Similarly, we can prove remaining two results. By using this property, we are going to apply the very important property tan inverse of x plus tan inverse of y, which is equal to tan inverse of x plus y divided by 1 minus xy. The condition should be satisfied, xy is less than 1. Second one, tan inverse of x minus tan inverse of y, which is equal to tan inverse of x minus y divided by 1 plus xy. Xy is greater than minus 1. First result, I am going to prove it. Let tan inverse of x is equal to theta, tan inverse of y is equal to pi. Then x is equal to tan theta, y is equal to tan pi. Now tan a plus b formula if I apply, theta plus pi is equal to tan theta plus tan pi divided by 1 minus tan theta tan phi, which is equal to x plus y divided by 1 minus xy. So theta plus pi is equal to tan from left to right, tan inverse of x plus y divided by 1 minus xy. Therefore, the formula should be tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus xy. By using this tan inverse of x, tan inverse of y formula, I am going to solve one problem. Tan inverse of 2x plus tan inverse of 3x is equal to pi by 4. Solution, tan inverse of 2x plus tan inverse of 3x, which is equal to pi by 4. By using formula, first formula, tan inverse of 2x plus 3x divided by 1 minus 2x into 3x, which is equal to pi by 4. Simplify this numerator and denominator. Tan inverse of 5x divided by 1 minus 6x square, which is equal to pi by 4. Tan inverse from left to right, 5x divided by 1 minus 6x square, which is equal to tan pi by 4. Tan pi by 4 is 1. Cross multiply 6x square plus 5x minus 1 equal to 0. Finding the factors, 6x minus 1 into x plus 1 equal to 0. X is equal to 1 by 6 or x is equal to minus 1. Since in this case x is equal to minus 1 does not satisfy the equation, as LHS of equation becomes negative. So x is equal to 1 by 6 is the only one solution of the given equation. Thank you.